The computers I see are good. All right. So real quick, I'm not going to go through that whole handout that I did last time, but hopefully I made the point pretty well. What's the area under a probability distribution? If I have some probability distribution, let's say a normal distribution, and I find that area there. And let's say that's from like 0.13 to 0.94. Can somebody tell me what that area really represents? Let's make this a little more real. Because that was like z-scores. Let's say this is somebody who's 68 inches tall to 73 inches tall, and I find this area. Find an area for that. How does that area relate? What does it mean in the real world? Say it. Sweet, that's one way to say it. So it's the percentage of people that are between those two heights. It's also...
The difference between those two ones?
I see what you mean. That's more of a calculation question. This is a conceptual, what does it mean question. So if I said there's that 10% of you guys are left-handed right now, how does that relate to the question of picking one person and figuring out probabilities? What does that 10% relate to? So if this was, let's say this is 10%. So 10% of the population would be between those two heights, if that's what I found. You with me? But how else can I interpret that? How else can I interpret that? In that context of chapter 4, maybe, whose title is Probability. I love it. One of the people would be, and that's still kind of a percentage question. So it would be, if I pick somebody at random from the population, there is a 10% chance that they would be in between those heights. You with me? So percentages are directly related to probabilities, and now visually, areas are directly related to probabilities. So it all boils down to what we did on that handout the other day was we saw how very simple shapes are nice. We know the area of a rectangle. But I talked to my calculus kids for a little while. I said, you guys know a little bit more how to find the area under this shape. If you didn't take calculus, you don't have a clue. Because what shape is that? It's a normal curve. Do you know the area formula for the shape under the... No. It's not length times width, right? It's freaky. Because this part is all curvy. It's never easy. That's what calculus does really well. It says, I don't care if you're curvy, you can find your area. So somebody, thank God, put all those areas for me on that table, the z-score chart. So if you have the insert still for your book, do I still have my insert? I don't know. I used to. Or in the very, very back of your book, hopefully not looking like it was chewed up, like mine does. There's the z-score chart. With me? So let's all kind of find it. Everybody finds z-score chart. Some of you guys got a copy of it. Some of you guys have the insert from the book. Some of you guys have the book. And some of yous are just going to have to sit there. So if you have the insert, it's right there in the beginning. Negative and positive. Now, I kind of got into a little bit. It's really difficult as students to see how the math that we do really relates to our everyday life. And that's one of the most common questions I get is, what does this got to do with me and my, going to the grocery store? What the hell? What does almost anything that you're interested in have to do with you going to the freaking grocery store? I hate that kind of question. But the way this relates to our everyday life, we did a very quick example, like how tall do you want this door to be? Like, let's say that you have a certain height and you want so many floors. Well, how tall is each floor going to be? And then how many people are going to be pissed off because they're hitting their head? Or they got a duck and their back's going. You kind of with me? And we also talked a little bit about airlines and how much they want to overbook. And let's say they want to say, I want less than 2% of the people to be upset. Well, then you can tell exactly how much to overbook by if you do exactly the math that we're talking about. So this math is stupid applicable. This is why I love teaching stats, because it's immediately applicable to the real world. So let's do a quick review question. this is chapter 6. So say I have a normal distribution. And the mean is 110. And the standard deviation is, let's say, 27. Why not? And I want to know what the probability is. Say this is like some kind of a standardized test. I want to know what's the probability somebody made more than 150. Well, about how many steps up from 110 is 150, and it kind of makes sense. If we know the empirical rule, the number of steps I get away from the mean, that tells me that there's less and less stuff in front of me. So you can imagine a little dude walking. The farther I get above the mean, there's less and less stuff above me. Or you can think about it, the farther I walk, the more stuff there is behind me. You guys kind of with me? So that chart tells you exactly how those probabilities fall. So if I just know how far away this is, I know how much stuff is left beneath it. And if I know how much stuff is beneath it, I know how much stuff is above it. Because the whole thing has to be what? 1. 100% for all the probabilities. I love it. So what's the first step here then? How do I figure out how many steps away that is? Z formula, I love it. So Z is x minus mean over the standard deviation.
150 minus.
Yeah, 150 minus 110 over 27.
1.48.
I like it. So how many places do you think the Z-score is going to always go?
2.
2, because the chart goes out 2. Right? So all your Z-scores truly rounded. So if you get 0.6666, don't make it 0.66. Round it to 0.67, right? So this will be 1.48. 2 places meaning 2 decimal places, right? Like go out to the 100th place. Now if you look that up on the chart, you guys weren't here last time. It takes a little bit of getting used to, but it's not that bad. Well, that was anticlimactic. I want to push a button and something happened.
For the test, are we going to have to have these?
Yeah, so for the test, today I really didn't have enough time. I just printed a few of these out. But for the test, you cannot use your insert. Your insert has way too much information on it. So I'm going to give you copies of the Z-score chart, the negative and the positive for tests. Pretty much after test 1 and give it to you, and you just keep it. Cool? Don't lose it. Yeah. It'll cost you $5 for it. No, I'm sure. Better than a DMV. Oh.
No, the DMV, you have to fill out a form.
Exactly. You have to take a number and sit down. So, this is negative. That's probably bad because my Z-score is positive. If we look at the Z-score, 1.48. So if you weren't here last time, here's how you read this sucker off. Can't see all the way over there. Is that cool? So if I want 1.40, that would be there. 1.4, the second decimal place is above there. So 1.48, it's right there, 0.9306. So 93% of the people were below it. Good. So 93% of people would have scored below it. So if I scored a 150, what percentile would I be in? 93rd percentile. It's crazy. So far, so good? Now, why is that okay but not good yet? Yeah, so I know this is 0.9306. So what must this be?
1 minus that.
1 minus that. The rest. 0.0694. Is that cool?
Yep.
What do you get when you look up negative 1.48?
That answer?
You get that answer. Because of the symmetry. If I look at negative 1.48, negative 1.4, 8.0694. How incredible is that as a shortcut? Not very. That would save you like seconds. Right? But if you think about it and you understand it, use it. Why the hell not? 4 seconds adds up over time, right? I would take a 5 cent per hour increase in my pay. What the hell? It adds up over time. That's all I can get. Actually, I get paid by the hour anymore. So the first thing you do is you find the z-score. You look that up. The minute you look it up in the chart, especially for my newbies, my oldies who were here last time, for a strange word. When you look it up in the chart, what do you always find? What does it always tell you? These are areas where? Below. Beautiful. So when I look up a z-score, it always tells me the area below. So if the question is about above or between, I've got to do a little bit of adjusting. How are we doing so far? Okay. This is almost too easy to realize how powerful this is. Now, the whole thing behind this, though, is what do I have to know about what I'm working with? Can I use anything? Can I use this for anything? If I could, that would be stupid good. That would be crazy. But, of course, I can't. What's this only work with?
Normal.
Normal is the key. So a big chunk of the rest of this semester will be, when is it normal so I can use all this? Because if I don't know it's normal, not only do I not know this beautiful detail of all these z-scores, I don't know shit. So I'd like to know if it's normal, I know all this. Any probability question you ask me, there it is. Who cares? I look it up, I'm done. If it's not normal, shit, that's statistics too. We don't really get too much into it. A little bit we'll get into it, but not too much. So what I want you to do right now is immediately find somebody, if you didn't end up with a z-score chart, somebody that has one, and I want you to work on this. You work on this together. I'll show you after this. Show you after this. Sure, anytime. So again, you can work together or alone. Call me over if you need some help. This is just real nuts and bolts stuff. Hello. Robin Williams kind of thing. Rainbow stripe in there, and it did stand up a long time. And it's working.
Let me guess, the mean is 0.
Say again? Sorry?
It doesn't say what the mean is on us. 0.
Oh. What's the question say? I mean, what's the actual question?
Give
Probability
us
of...
distribution 5.
Probability of what? For part A.
Z 1.45.
It's already Z. So guys, when do you have to use this formula? When you don't have the z-score, what do you have in number 1?
Z-score.
Beautiful. So that's the step you can skip for number 1 because you already have a z-score. So 6.2, it gives you nothing but z-scores. 6.3 gives you x scores. And you have to first can change it into a z-score.